Your team studies people that you call super agers. Can you define that term for us? What is a super ager?
It started with this theoretical idea that when we think about aging, most of the time the news is bad. We think about what's going wrong, whether it's changes in our eyesight, our hair turning gray or falling out, or other external changes. But we know that also there's changes happening inside of our body, including changes in memory performance. Our memory is not as good as it used to be. And so, while that's true on average, most people can also say, gosh, you would never believe my aunt, uncle, neighbor, whoever it is, they act like they're in their 30s. And so that was the theoretical premise of there are people out there who age at different rates or different trajectories. And then since we're scientists, we want to put rules around that and guidelines. And so we define superagers as people who are over age 80 because that means they're at the biggest risk for memory loss, but that have memory performance at least as good as individuals in their 50s and 60s.
So once you've found your super agers, how do you study them? What exactly are you measuring?
We say, well, what factors are allowing them to have that great memory performance? So we invite participants in and then they're with us for life. So they keep coming back over time. And then eventually we ask them to donate their brain at the time of death. This is critically important. It might sound a little bit scary, but during life, we can see with a specific resolutions. If you remember way back when we had the first digital cameras, everyone was excited because you could take pictures very rapidly and as many as you wanted without having to use film. But then when you printed them out on your computer, they were very pixelated. This is kind of the same resolution that we can see with during life.
Right.
And so when people give that ultimate gift of donating their brain at the time of death, we can see with a better resolution. We can look at the cellular and molecular factors in a way that is much more difficult during life or just nearly impossible. So getting back to your question of what do we study when we look at superagers, we're interested in the biologic factors, the genetic factors. What does brain structure look like? We ask superagers to participate in an MRI scan. So this gives a 3D image of the brain. We ask them to donate blood so that we can look at genetic factors. Now, we realize things are more complicated than these biologic factors because we live and survive and walk around and talk and have 80 plus years of lived experience. And we're interested in that too. So, how does family history play a role? Education, lifestyle factors, psychosocial factors. So the way that we've set this up is to be really comprehensive of not looking just at these pillars, but also the integration among these pillars so that we can understand the factors that are helping people live long and live well.
Well, that's incredible. I mean, you just described the whole ecosystem of factors and disciplines you look at. What have you found as common traits in what you're defining as superagers?
We're at the beginning of this journey, not at the end, but we've already found many things that are really exciting. So when we look at brain structure, we asked a really simple question. What does the structure of their brain look like? Does it look more like the 80-year-olds who they share in chronologic age with? Or does it look more like the 50-year-olds who they share memory performance with? And so we answered this really simple question with complex technology that allows us to look at the outer layer of the brain called the cortex and to look at the thickness of that. And what we know happens with aging is that our brain shrinks with time. And when that shrinkage occurs, it's associated with change in cognition. And when we compare the thickness of average 80-year-olds to average 50-year-olds, we see lots of shrinkage across the whole surface of the brain. But when we compare superagers to the 50-year-olds, their brain thickness is not significantly different from that of the 50 to 60-year-olds. And then we found one more surprising thing is that deep in the middle of our brain, in an area called the anterior cingulate, we found that the superagers actually had a thicker part of their brain.
What are your ultimate hopes from studying superagers?
We see it as an opportunity to understand what are the protective factors so that we can be building up our protective factor muscles instead of just avoiding risk factors.
What can the average person take away right now from your studies?
So I think what our studies support, that's really in line with larger spheres of science that have shown this as well, is that relationships matter and staying connected matter. So we know that there are severe and negative consequences of social isolation and loneliness. If I was to offer one suggestion today, it would be, call that friend on the way home, make that connection. For some people, that might be gathering in a large group, and for other people, that might be calling a trusted friend. But whatever that means to you, that social connection is important. The other thing is that our brains like to be challenged. So often people will ask, "Ooh, how many crossword puzzles do you think I should do a week?" And the answer is, do you like crossword puzzles? Do you find them challenging? Now, if you hate crossword puzzles, cut them off. They're not helping you out because stress, especially chronic stress, we know is bad for the brain and actually has physical changes that take place to the brain. So, finding things that you enjoy, but that also challenge you, we know to be really important for our brain and our brain health.